cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
A single star can light up the night sky. But have you ever wondered what happens when a star dies? It doesn't just fade away. Sometimes it goes out in a blaze of glory, unleashing an explosion so powerful it can outshine an entire galaxy. These cosmic fireworks are called supernovas, and they are, without a doubt, the most violent and spectacular events in the known universe. Join us as we journey into the heart of these stellar cataclysms. So, what exactly is a supernova? Imagine a star many times more massive than our sun. For millions or even billions of years, it burns through its fuel, balancing the inward pull of gravity with the outward push of nuclear fusion. But all stars eventually run out of fuel. When this happens to a massive star, the delicate balance is shattered. Gravity wins. The star's core collapses in on itself in a fraction of a second, shrinking from the size of a planet to a city-sized ball of incredibly dense matter. This catastrophic collapse triggers a rebound, a titanic shock wave that blasts the star's outer layers into space at nearly the speed of light. This cosmic detonation is a supernova, releasing an unimaginable amount of energy and light. It's the final dramatic breath of a dying giant. Not all supernovas are created equal. Astronomers classify them into different types, but the two most common are Type 2 and Type Ia. A Type 2 supernova is the classic scenario we just described. A massive star, at least 8 times the mass of our Sun, exhausting its nuclear fuel and collapsing under its own gravity. Its death is a solitary, violent event. A Type Ia supernova, however, is a bit different. It involves a pair of stars orbiting each other, a binary system. One of the stars is a white dwarf, the dense, burnt-out core of a sun-like star. If this white dwarf pulls too much material from its companion star, its mass can reach a critical limit. This triggers a runaway thermonuclear reaction that completely obliterates the white dwarf in a blindingly bright uniform explosion. Both types release more energy in mere seconds than our Sun will generate over its entire 10 billion-year lifetime. Now let's talk about the record breakers. In 2015, astronomers witnessed something truly mind-boggling. They detected a flash of light so intense it defied explanation. Named Assassin 15MH, it was one of the most powerful supernovas ever recorded. At its peak, it shone with the light of 570 billion suns. If it were as close as Sirius, our brightest night star, it would appear as bright as the full moon. This event was so extreme, it pushed the boundaries of our understanding of astrophysics. In fact, its sheer power led some scientists to question if it was a supernova at all. An alternative theory suggests it might have been an extremely rare and powerful type of neutron star called a magnetar, unleashing a colossal burst of energy as it spun down. Whatever its true nature, Assassin 15LH remains a stunning cosmic mystery. A supernova isn't just an act of destruction, it's also a powerful engine of creation. The incredible heat and pressure in a supernova explosion are the only known natural processes in the universe capable of forging the heaviest elements. Elements like gold, platinum, and uranium, which are essential for life and technology on Earth, were all born in the fiery crucible of a dying star. But that's not all. The shock wave from a supernova travels across the galaxy, compressing vast clouds of gas and dust. This compression can trigger the gravitational collapse of these clouds, giving birth to new generations of stars and planetary systems. In this way, the death of one star directly seeds the creation of countless others. It's a beautiful, violent cycle of death and rebirth that constantly shapes and enriches the cosmos. So, are there any of these cosmic time bombs ticking near us? Could a supernova pose a threat to Earth? The good news is no. Fortunately, all the known stars massive enough to go supernova are safely far away, well outside the kill zone of about 50 light years. But that doesn't mean we won't get a front row seat to one of these events. Take Betelgeuse, the bright red star in the shoulder of the Orion constellation. It's a red supergiant, a star in the final stages of its life. It's around 650 light-years away, and scientists know it could explode at any time, tomorrow, or 100,000 years from now. When it finally does, it will be a spectacular sight. Betelgeuse will become so bright it will be visible during the day and will cast shadows at night, remaining as bright as the full moon for weeks. It will be the greatest light show in recorded human history. What happens after the dust settles and the light from the explosion fades away? What's left behind? For a supernova, there are only two possible fates, and both are among the most extreme objects in the universe. If the original star wasn't too massive, its core will collapse into a neutron star. This is an object so dense that a single teaspoon of its material would weigh billions of tons. But if the original star was truly massive, more than 20 times the mass of our sun, gravity will be unstoppable. The core will continue to collapse indefinitely, crushing itself down to a single point of infinite density, a singularity. This creates a black hole, an object with a gravitational pull so strong that nothing, not even light, can escape. These stellar remnants are the bizarre, fascinating ghosts that supernovas leave behind, forever warping the fabric of space and time. From a single star illuminating the darkness to a galactic explosion that forges the elements of life, supernovas are a powerful reminder of the immense scale and dynamic nature of the cosmos. They show us that the universe is a place of both incredible violence and profound creation. The next time you look up at the night sky, remember that every atom in your body, the iron in your blood, the calcium in your bones was forged in the heart of a star that lived and died long before our sun was born. We are, quite literally, made of stardust. Thank you for joining us on this cosmic journey. If you enjoyed this exploration of the universe, don't forget to like, subscribe, and hit that notification bell for more adventures into the great unknown.